In this final video related to linear inequalities, we're going to look at some applications. And, well, as you might know, applications are a synonym for word problem. So here we go. So every day nowadays, or I should say nowadays, everybody has a cell phone with unlimited, well, nearly unlimited data and texting and all that stuff. But believe it or not, a while ago you were charged per text message that you sent. So, so what you would pay for was you'd pay for a base fee for allowing the company to use their services, and then you would be charged by the number of text messages you sent. And there was an associated price per the text message. And then there was roaming, which we won't talk about. But anyway, word problem. Two companies have competing plans, Company A, Company B. Company A charged $15 per month for their base fee, and then they had 10 cents per text that they sent. And then Company B said, okay, charge a higher price, but have a lower per text fee that they charged. And so if they want to limit their bill, if a customer wants to limit their bill to $40 a month, what is the range of text messages they could send under each plan and still achieve the goal? So here, as you can imagine, we're going to mathematize all this. So I'm just going to write some information for A. So it was $15, and then and I'm going to put it in dollars. So 10 cents per text. Okay, and then B was, okay, $30 and 5 cents per text. Okay, and now the customer wants to limit their bill to $40 per month. Okay, so limit, okay, when I think of that, that's like a value that you cannot exceed, right? So if I think about that $40 limit, the bill should be less than or equal to that, right? So under plan A, it would be charged $15 plus 0.1, and then let's call it X, and I'm going to define X, actually use that in both scenarios. X is the number of texts sent per month. Or, yeah, per month. Yep. In a month, I'll say in a month. Okay, so then this first one, 15, all that, so then, okay, subtract 15, you get 0.10x, and that's equal to 25, and then also, I'm not a big fan of decimals, so I would rather write this as x over 10 for 1/10, and then so you multiply by x, and x has to be less than or equal to 250. Okay, versus in plan B, okay, so we have 30 plus 0.05, x is less than or equal to 40, okay, so again, the base fee plus some number of texts has to be less than or equal to $40, subtract 0.05, x is less than or equal to 10, and if you didn't know this, 0.05 or 5 hundredths is the same as 1 over 20. So then x is less than or equal to 200. So it's kind of clear that maybe, well, okay, so, and then we could interpret this in context. X would be, so number of text messages under plan A would be 250 versus plan B is 200. So which one is a better plan? Well, this is a little bit of opinion and a little bit of math. So if it was me, I don't text that much, so, well, maybe I do. I really haven't kept track in a while since I have unlimited texting now. But anyway, I would probably go with plan A, just because you can have a higher number of text messages, and still be under that $40 a month, or at or under, I should say. For the second one, it's not a bad deal, but this one would charge you less per text. So if you're a person that texts a lot, like send thousands of messages, for instance, maybe you want plan B even though you have a higher base price. So the second question about better plan, again, make an argument, stick with it, and you'll be good. But this exercise in this video is really meant to illustrate taking text and converting it into math. So we used the information that we had, and we had to define a variable. So again, if a variable is not defined, you need to do that. And then at the end, we just kind of processed the math for both of them using our previous knowledge of linear inequalities and arrived at an answer, or at least a mathematical answer. Then we had to interpret it. Okay, so that's going to wrap up our discussion on linear inequalities.